Assalamualaikum warahmatullahi wabarakatuh. My name is MuazJ, and now I would like to proceed to the next slide, which is introduction. So, for the introduction of humidification, humidification is the process of elevating the level of water vapor present in the atmosphere. For example, elevated humidity levels help to eliminate problems such as mold and also suppress bacteria to maximize the longevity of produce. Otherwise, humidified systems produce a cooling effect, which is useful in storage facilities, although this aspect of climate control is crucial to many industrial processes. So, I would like to explain about how to read the psychrometric chart. Okay, so the first step, locate the dry bulb temperature along the bottom axis and the associated vertical line for each temperature. This scale will be in degrees Fahrenheit or degrees Celsius. Next, step 2, locate the humidity ratio along the right vertical axis. Humidity ratio units are grains of moisture per pound of dry air or grams of moisture per kilogram of dry air. The term humidity ratio is sometimes used interchangeably with the term mixing ratio. Next, step 3, locate the leftmost curved line. This is the saturation curve where the relative humidity is 100%. Other properties of the saturation. The curve includes dew point temperature that equals to dry bulb temperature, where bulb temperature is equals to dry bulb temperature. Partial pressure of water vapor is equals to saturation vapor pressure. So, for the next step, which is step 4, locate the interior curve lines. Each of the lines represents a certain level of relative humidity in percent. Okay, so let's continue to the next step, which is step 5. Okay, for the step 5, on the other side of the vertical line, where to located the dew point is the scale for vapor pressure, expressed in inches of mercury or millibars. Vapor pressure lines also traverse the chart as a horizontal line. Next, for step 6, on the right side of the chart, locate the vertical line labeled dew point. Dew point is expressed as a temperature. The dew point line traverses the chart as a horizontal line. What this tells you is that the dew point does not change as the dry bulb temperature varies. So, then, step 7, look at the information on all sides of the chart that is on the most extreme edge. This scale represents enthalpy expressed in BTU per pound of dry air. If you take a ruler, you could match the scales diagonally across the chart. And last but not least, step 8, look closely and find a second set of diagonal lines representing wet bulb temperature, expressed as degree Fahrenheit or degree Celsius. Although the wet bulb lines are close to the enthalpy lines, they are not actually parallel to each of other. As we can see, based on the diagram psychrometric chart shown, that first, the step 1, locate the dry bulb temperature along the bottom axis and associate vertical line for each temperature. And for the step 2, that you must locate the humidity ratio along the right vertical axis. And look at the step 3, locate the leftmost curved line. This is saturation curve where the relative humidity is 100%. And look at the step 4, locate the interior curve lines. Each of the curve lines represents a certain level of relative humidity in percent. And look at the step 5, on the right side of the chart, that you must locate the vertical line labeled dew point. The dew point is expressed as a temperature. The dew point lines traverse chart as a horizontal line. So next, look at the step 6. On the other side of the vertical line where you located dew point is the scale for vapor pressure that expressed in inches of mercury or millibars. So the vapor pressure lines is traversed to the chart as a horizontal line. And for step 7, so you look at the point 7. Look at the all sides of the chart that is on the most extreme edge. So this case represent enthalpy that expressed in BTU per pound of dry air. If you use a ruler, you could match the scales diagonally across the chart. And lastly, look at the point 8, which is step 8. Look closely and find a second set of diagonal lines representing wet bulb temperature that expressed as degrees Fahrenheit of Celsius. But at this study, we must use Celsius for our schematic. So the wet bulb lines are close to the enthalpy lines, but they are not actually parallel to each other. So for each steps, these steps can guide you to make a curve and find the calculation about the psychrometric chart. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rasmyie bin Abdurrahim. My metric number is AA21106. Today I want to discuss about the part B, which is problem statement of humidity chart. Number 1 is I will explain and the three problem about humidity. So the example number 1 is we are given a mixing ratio of 4 gram per kilogram and an air temperature of 80 Fahrenheit. We'll begin by creating a 4-column chart. Column for the air temperature mixing and saturation matching ratio and dew point temperature. So the question is calculate the relative humidity, which is RH. Okay. So firstly, we start by entering the data we were given in the table. Once you know the air temperature, you can look up the saturation mixing ratio value. It is 20 gram per kilogram for the 80 Fahrenheit air. 80 Fahrenheit air could potentially hold 20 gram of the water vapor per kilogram of the dry air. It actually contains 4 gram per kilogram in this example. A table of saturation mixing ratio value can be found of the P86 in the class note also. Okay, next. Once you know the mixing ratio and the saturation mixing ratio, you can calculate the relative humidity. So firstly, you divide the mixing ratio by saturation mixing ratio. 4 divide 20 and multiply the result by 100%. And then finally you get the RH, which is 20%. Okay, for the question number 2, example number 2. How to solve? So firstly, we imagine cooling the air from the 80 Fahrenheit to the 60 Fahrenheit and then to the 55 Fahrenheit and finally to the 55 Fahrenheit. And then at each step we look up the saturation mixing ratio and enter it on the chart, and then note that the saturation mixing ratio value decrease as the air is cooling. And then the mixing ratio doesn't change as we cool the air. The only thing that changes just ratio is adding or removing water vapor, and we are doing either. And finally, note how the relative humidity is increasing as we cool the air. The air still contains the same amount of the water vapor. It is just the air capacity is decreasing. So we conclude at the 45 Fahrenheit in the at the RH there's been relative humidity become 100%. We have to cool the air until it has become saturated. This is the definition of the dew point temperature, and the dew point temperature is in this problem is 45 Fahrenheit. Okay, for the question number 2, example number 2. So, how to solve? So, firstly, we imagine cooling the air from the 80 Fahrenheit to the 16 Fahrenheit, and then to the 55 Fahrenheit, and finally to the 55 Fahrenheit. And then at each step, we look up the saturation mixing ratio and enter it on the chart, and then note that the saturation mixing ratio value decrease as the air is cooling, and then the mixing ratio doesn't change as we cool the air. The only thing that changes this ratio is adding or removing water vapor, and we are doing either. And finally, note how the relative humidity is increasing as we cool the air. The air still contains the same amount of the water vapor. It is just the air capacity is decreasing. So we conclude at the 45 Fahrenheit in the at the RH there's been relative humidity become 100%. We have to cool the air until it has become saturated. This is the definition of the dew point temperature, and the dew point temperature is in this problem is 45 Fahrenheit. Okay, last but not least is example number 3. Question is, we are given the two conditions. An A temperature of the 80 Fahrenheit and a mixing ratio of the 4 gram per kilogram. First, let's create a 4-column chart. Column for the air temperature, mixing and saturation mixing ratio, and the dew point temperature. What would happen if we lower the air temperature any lower below the dew point? So we must solve the problem. So the ways to solve the problem is 35 Fahrenheit can all the 4 gram of the water vapor. That 35 Fahrenheit air can. So you can only fit 4 gram of the water vapor into the 35 Fahrenheit air. The remaining 2 gram will condense. If this happens at the ground level, the ground will get wet with the dew. If it happens above the ground, the water vapor condenses onto small particles in the air and form out a cloud. Now, because water vapor is being taken out of the air and being turned into the water, the mixing ratio will decrease from 4 to number 4 to 2, number 2. I think this is from me. So thank you.